Have you ever seen an AI do something absolutely brilliant, like solve a really tough problem, and then just a second later, it makes a super simple, baffling mistake? Well, today, we're going to break down one of the most clever techniques out there for making AI reasoning way more reliable. It's called self-consistency, and we're going to look at exactly how it works.
So it really all boils down to this one question. How do we get these incredibly powerful language models to be not just brilliant once in a while, but actually correct consistently? Well, the answer, it turns out, is a strategy we humans use all the time. We get a second opinion.
All right, so first, we've got to get our heads around the real problem here. And that's the fact that an AI's step-by-step thinking can be surprisingly fragile. Look, large language models, or LLMs, are amazing with language and logic. But when you give them a multi-step problem, they're basically walking a tightrope. One little slip-up, one tiny error early on, and the whole thing can just completely fall apart.
This diagram shows you exactly what I mean. That top path, that's the greedy approach, where the AI just picks the most likely next step. But see that one part highlighted in red? That's it. That one little mistake at the beginning totally poisons the well, leading to a completely wrong answer. It doesn't matter if every other step was perfect. That single point of failure means it's game over for that line of thought.
So if taking just one path is that risky, what's the solution? Well, what do you do when you have a really tough decision to make? You ask a friend, right? You get a second opinion. Or, in this case, you get a whole crowd of them.
Now check out the bottom of the diagram. This is self-consistency in action. Instead of just one path, we let the model come up with a bunch of different ways to think about the problem. Yeah, some of them still get the wrong answer. But here's the magic. The majority of these different paths all point to the same correct answer. By looking for the consensus, we find the truth.
So, to put it simply, self-consistency is basically a majority vote for an AI's thoughts. You ask it the same question a bunch of times, let it come up with different reasoning paths, and then you just bet on the answer that pops up the most. It's a super simple but really powerful way to weed out those random mistakes.
You know, the researchers who came up with this idea put it perfectly, and it taps into something very human. As the quote says, when you have different ways of thinking that all lead to the same conclusion, you just feel more confident that it's right. Self-consistency is basically just programming that common sense right into the AI.
Okay, so this idea of getting multiple opinions is awesome, right? But there's a catch. It's kind of slow. So the next big step in this whole story was figuring out how to get all the benefits of asking a crowd without, having to pull the entire city.
I mean, think about it. Asking an AI to solve a problem 40 times is way more work, computationally speaking, than asking it just once. If you need a fast answer, that could be a total deal breaker. So the question became, can we do this better and faster?
And this led to a really brilliant next step. On the left, you've got the standard method. One path, one vote. Simple. But on the right, we have something new. Confidence-informed self-consistency, or CISC. With this method, we don't just ask the AI for an answer. We also ask it, hey, how sure are you? The answers where the model says it's really confident, those get a bigger say in the final vote. And wow, the results are just incredible. Look at this graph. See the blue line? That's the standard method. It needs about 30 different reasoning paths, 30 samples, to even break 50% accuracy. Now look at the orange line. That's the confidence-weighted method. It flies past that same accuracy level with just 8 samples. That is a massive efficiency gain. In fact, that's a potential 73% reduction in how much computation you need. It's like the difference between asking 30 friends for their opinion versus just asking your 8 most confident friends. You get a better answer, and you get it faster and cheaper. We're not just counting votes anymore, we're weighing them. Okay, so a majority vote is great when the answer is a simple number or a choice, like in a math problem. But what happens when the answers get messy, when they're complex and open-ended? This was the next huge hurdle to clear. Right? If you ask an AI to summarize a report 10 times, you're going to get 10 slightly different summaries. None of them will be identical. You can't just count them up. The same thing happens with writing code. So how do you find the consensus in all that free-form text? The solution is called Universal Self-Consistency, or USC. And honestly, it's so clever. First, you generate all your different answers, just like before. But then, and this is the genius part, you bundle all of those answers together and you feed them back to the AI with a new prompt. You just ask the LLM itself to pick the one that best represents the consensus. You're using the AI's own understanding of language to solve the problem. It's brilliant.
So, we've gone on this whole journey. From a single, fragile path to a whole crowd of opinions to a smarter, weighted vote, and now a universal method that works for pretty much anything. So let's just pull back for a second and look at the big picture here and what this all means for the future of AI.
So what's the big payoff? Well, yeah, we get AI that's more accurate and more efficient, for sure. It works on everything from math to creative writing. But the biggest benefit, the most profound thing, is that last one, a built-in uncertainty check. When all the different reasoning paths lead to a jumbled mess of answers, that's a huge signal that the AI is confused. For the first time, the model has a reliable way of saying, hey, I'm not sure about this one. And that is a crucial step towards building AI we can actually trust.
And that really brings us to our final thought. An AI that can tell you when it's not sure, that's a totally different kind of tool. It's not some black box just spitting out answers anymore. It's more like a collaborator that can tell us when we need to be careful, when we need to double check. So the real question for all of us is, as these systems get better at knowing their own limits, how is that going to change the way we work with them, and maybe more importantly, how we learn to trust them?